Hello everyone, welcome to Dev. I'm Much. This is the 30-day Python challenge and today is day 5 and we're diving into what might be one of the most important aspects of Python development, lists. So if strings were about handling text and lists are about handling collections of anything, think of them as Python's Swiss Army knife, right? Incredibly versatile and useful in almost every program you'll ever write. So by the end of this video, I would like you to understand what this fundamental part of Python is, and hopefully you can learn how to manipulate the lists like pros, as well as utilize them in your future programming. Let's get into it. So what exactly is a list? In simple terms, a list is an ordered, changeable collection of items. But let me break it down in simple English. So, an ordered list, which means items have a specific position, we call this the index. Changeable would mean that you can change the list after creating it, like adding and removing and modifying items within them. A collection would mean that it holds multiple items, and the cool part about this is that they can be of different data types. So there are 4 types of collections of data types, right? A list, as we know, which you just explained, is obviously an ordered, changeable collection of items. A tuple, which you went through before, which is obviously a collection which is ordered and unchangeable, allowing for duplicate members. There's a set, a collection which is unordered, unindexed, and unmodifiable, but we can add new items to the set, but no duplicates are allowed. Dictionary, a collection which is unordered, changeable, and indexed, and also no duplicates are allowed. So if you look at this example of code, a mixed list can contain strings, integers, booleans, floats, and even other lists, right? This flexibility makes lists incredibly powerful for representing real-world data. So moving on, let's get data out of a list. We use indexing and slicing similar to what we learned with strings. So there's positive indexing and negative indexing. Positive indexing, we can access each item by using the indexing which starts from 0. So indicated here, you can see it starts from 0, 1, 2, 3. The negative indexing will start at -1 rather than 0. So turning the end to the beginning of the list, like so. Therefore, -1 obviously refers to the last item on the list, and -2 to the second last item. This becomes useful with list slicing. The last one is Pythonic way of reversing the list without any loops. If we look at positive slicing, we can specify a range of positive indexing by specifying the start, end, step, and then the return of the value will be a new list. Now with negative indexing, we're specifying the range of negative index by again specifying the start, end, and the step, and then return a new list. So remember how strings cannot be changed? Well, lists can be changed, meaning it can be changed after creation, giving its flexibility. This is where they become very useful. You can change the index value of the list by calling the index of the list and assigning the string or integer to that index position. You can remove an element from the list using pop or remove. When using pop and not specifying anything, it will remove the last index value from the list. When using remove, you must specify what it is you want to remove. Another way is to also use del for delete, followed by the index you wish to remove. This is also used obviously for deleting or clearing the entire existence of the list itself. For adding to the list, You use append or insert. Using insert, you must specify the place you are going to add the element indicated by the index. We can also do bulk operations in list and combine them as well. If you have two lists, like in this example, you can use this plus operator to combine the lists together. To perform repetitions, however, you use the asterisk operator to repeat the list any given number of times. So here's a hands-on approach to things, right? Python gives you a rich set of methods to work with. Let's see how. We sort the list with sort. We specify the condition of reverse to be true and the order of the list will reverse. So given this example, right? It's pretty straightforward. So assign a sorted list to another variable to not change the original list. Operands such as len, min and max and sum finds the respective length, the minimum, the maximum value of the list and also calculates the sum of the list. You can find the index position of a value in the list and count the amount of items an element occurs in the list with the respective index and count function. So in this example, you can clearly see that if you call upon the value within the list, it will respond with a number that reflects back to you when you're using count. So obviously if you have like two values of 2, it will return 2. So let's get into more complex issues. This is list comprehensions. Let's say we want to create a list of squares from 1 to 5. This would be the traditional way of doing things. Now let's do things using lists. We assign the variable squares a list which includes a loop. This is no different from what we used before in the previous example. It's just in one line, shortening the amount of lines of code that you'll use in any case when you're using a loop. We can go a step further by including addition to it, or when using strings, we make all the words either lowercase or uppercase. So we can obviously in a list of menus, if we want it to be all uppercase letters, we can use it in that sense. Or everything needs to be in lowercase, we can use it in that sense. So the whole list of menus will be in lowercase. Now let's look at the most common error points in all of our code that we all make from time to time, right? So if you assign a list to a new variable, you're creating a reference and not a copy. So in this example, you're obviously going to be making a copy, and the correct way to create a copy of a list is to use the function copy. Another error in the way we code is modifying while iterating. So this will cause many unexpected behaviors. So if modification while iterating is needed, it is best to iterate over a copy. So take a copy of the original list, iterate it, and then maybe append it to the newer version of a list. So if anything is with the original list, if you update it, iterate through it to see if, I don't know, the number of things are there, and then copy it over to or append it to the copy of the original. So this will be in the case of storing data, right? Or processing collections of data, building menus, or even development in terms of game development. And obviously that is something that we will definitely be getting into later on. We've covered a lot about lists today, from basics to advanced list comprehension. You've learned to access, modify, sort, and transform lists. I hope you learned something today. Leave a like and subscribe, and I'll see you soon.